All right, so let's talk about right triangles and the Pythagorean theorem. This has got to be the most famous theorem in all of mathematics, named for a guy named Pythagoras, and it describes the relationship within a right triangle, of the sides in a right triangle. So if we have a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the length of the legs. And the hypotenuse is the longest side. It is across the road from the right angle. So a squared plus b squared equals c squared. It does not matter which leg is A and which leg is B. The only thing that matters when you're setting up this problem is that you correctly identify the hypotenuse, which is the longest side. It's going to be across from the right angle. Okay, so now let's take a little side street and talk about a Pythagorean triple. And a Pythagorean triple is a set of three positive integers, i.e. whole numbers, that satisfies our Pythagorean theorem. So 3 squared plus 4 squared equals 5 squared, because 3 squared is 9, 4 squared is 16, 5 squared is 25, 9 plus 16 equals 25. That makes it a Pythagorean triple. And as it turns out, any multiple of 5, right, or of 3, 4, 5, so this is 2 times 3, 4, and 5. This is 3 times 3, 4, and 5. Or if we have 3x, 4x, 5x, that's going to be a Pythagorean triple. We're going to get whole numbers, no decimals to deal with. 5, 12, and 13, 8, 15, and 17, 7, 24, and 25 are the ones that you see most often. You don't have to memorize these because you can still do the Pythagorean equation to get to your Pythagorean triples and find out what they are. All right, find the value of x, then tell whether it's a Pythagorean triple or not. All right, so x is our c squared. So this is c, this is a, and this is b. Again, it doesn't matter which one's a and b. So 5 squared plus 12 squared equals x squared. So 25 plus 144 equals x squared. 169 equals x squared. Take the square root of both sides. The square root of 169 equals x. So 13 equals x. Yes. Pythagorean triple. Let's determine if this one is a Pythagorean triple or not. So again, our c is x. So a and b in some order is this. So 5 squared plus 4 squared equals x squared. 25 plus 16 equals x squared. 25 plus 16 is 41. Take the square root of both sides. I get radical 41 equals x squared. Radical 41 is not a perfect square, so no, not a Pythagorean triple. It works as easy as that. Let's do another example. In fact, why don't you pause the video, do this example, and then restart, and we'll see how you did. Okay, so CAB 7 squared plus x squared equals 14 squared, so 49 plus x squared equals 196. Minus 49, so x squared equals 147. Take the square root of both sides. Now, I'm not sure about 147, and I don't have my calculator on me, so I'm going to go ahead and reduce this down. 1 plus 4 is 5, plus 7 is 12, so it's probably divisible by 3. Divided by 3 would be 49. 49 is a perfect square, so that comes out, and I end up with 7 radical 3. Not a Pythagorean triple. Easy enough. Once again, go ahead and do this one. Pause the video, do this one, and then see how you did it. All right, so is this a Pythagorean triple? Well, since x equals 20, yes. How do I know that x equals 20? Because this is 5 times 3, this is 5 times 5, this is my c, so I get 3 squared plus x squared equals 5 squared if I divide everything by 3. It's a 3, 4, 5 triangle. So this is going to be 4 times 5, or 20. That's how Pythagorean triples can help you if you recognize them. All right, another way the Pythagorean triple theorem is going to help us is anytime we have a right triangle and we're missing the length of a side. If we have 2 sides, we actually know 3 sides if it's a right triangle. Because the only really thing we need to know is where is our C. So we're going to go 23.26 squared plus 47.57 squared equals C squared. So that's going to be this guy. So 23.26 squared is 541.0276. And I don't want to round too early, because if you round too early, later you've rounded a number, then you're using a rounded number, then you're using a rounded number. You get further and further away from the real answer. You want to wait till the very end to go ahead and round, so we can get as close to the absolute answer as we can. So 47.57 squared is 2,262.9049. And we're going to add that to our 23.26 squared, and we get 2803.9325. Then we're going to take the square root of both sides. And C is going to equal 52.95, or about 53 meters. Our calculator will do a lot of the work for us, but sometimes we need to be able to reduce those radicals. All right, actually, why don't you pause the video, do the next 3, then restart it and see how you did. Remember, the key is identifying which is our C. All right, so find the value of x. X is our c squared. So 52 equals x squared. We're going to take the square root of both sides. 52 is not a perfect square because the closest one is actually 49. So we got to reduce our radical. So 52 is divisible by 2. 26 is divisible by 2. So we got two 2's. 2 times 2 is 4. Radical 4 is 2. So 2 radical 13 equals x. And remember, the number under the radical is an exact number. And if we use our calculator, we're going to find out that we're going to have about 7.2. So this is not a Pythagorean triple. Find the value of x. Well, I've got a c of 5, a equals 3, b equals x. This is a 3, 4, 5 triangle. X equals 4. And just in case you don't believe me, let's just work it out real quick. Pythagorean triples at work, saving us time and energy. Find the value of x. Well, some of you have now caught on, and this is 3 times 3. This is 5 times 3. So x has to equal 4 times 3 or 12. So at least know your 3, 4, 5s, because when they pop up, they save us a ton of time. All right, so let's talk about the converse of the Pythagorean theorem. So we all recall that the Pythagorean theorem says in a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the length of the sides. And the converse, we reverse the hypothesis and the conclusion. So if the square of the length of the longest side of a triangle is equal to the sum of the square of the lengths of the other two sides, then it is a right triangle. So if a squared plus b squared equals c squared, then triangle ABC is a right triangle. Simple enough. But sometimes first we got to make sure it is a triangle, and we will recall that if it is a triangle, A plus B will be greater than C, B plus C will be greater than A, and C plus A will be greater than B. Any two sides will be greater than the third side. So all of that has to be true. So basically, if you take the two short sides, add them together, and they're bigger than the long side, you're good to go. You have a triangle. All right, tell whether the triangle is a right triangle. So when you look at these, don't assume that just because it looks like the longest side, it is the longest side, because the longest side is going to be our C. We need to identify that before we can make a determination. But we have 8, we have 7, and we have radical 113. Well, we know that radical 100 is 10, so radical 113 is the longest side. So a squared plus b squared equals c squared. If that is true, then it is a right triangle. So we get 64 plus 49, and radical 113 squared is radical 113 times radical 113, which is the same as saying 113 squared. And take the square root of 113 squared is 113. So we add 164 or 64 to 49, and we get 113 equals 113 right triangle. Same exact problem again. So let's get 36 squared plus 15 squared. Radical 95 is almost radical 100, so it's close to 40, so it's bigger. So 36 squared is 1296. 15 squared is 225. Now, this quantity squared is going to be inside with inside, outside with outside. So I get 4 times 4, which is 16, times 95, because this is 4 times 95. So I do the outsides, I do the insides. Not radical 95 times radical 95 is 95. Radical 95 squared. The square root of any square is just the number. So 16 times 95 is going to be 1520. 1296 plus 225 is 1521. This is not true. Not a right triangle. All right, so let's do 2 more examples. 8, 4 times radical 5, which is 4 times 2, which is a little bigger than 8. So we get 8 squared plus 4 radical 5 squared equals 12 squared. So 144 equals 64 plus radical 5 squared is 5 times 16 is 80. 64 plus 64, or 64 plus 80 is 144, which does indeed equal 144 right triangle. Let's do it one more time. 9 squared plus 2 radical 30 squared equals 14 squared. 14 squared is 196. 9 squared is 81. 2 times 2 is 4. Radical 30 times radical 30 is 30. 30 times 4 is 120. So 201 does not equal 196. Not a right triangle. And spoiler alert, it's going to be an acute triangle. All right, so our Pythagorean inequalities theorem, last thing we're going to talk about in this section. For any triangle ABC, where C is the length of the longest side, the following statements are true. If it is an acute angle, triangle, then a squared plus b squared is greater than c squared. And if it's an obtuse triangle, a squared plus b squared is less than c squared. And the way I remember it, big C, big triangle, little c, little triangle. Now, we got to make sure that we can actually form a triangle. And so this has to be true. The two short sides have to be larger than the largest side. If I add them together, the sum of the short sides got to be larger than the sum of the longest side. If it's not true, not a triangle. So we're going to determine whether segments with lengths 4.3, 5.2, and 6.1 can form a triangle. And if it is, what kind of triangle is it? So we're going to go 4.3 plus 5.2, and we're going to set that equal to 6.1. We're going to add them together and get 9.5 is greater than 6.1. So we have a triangle. So now let's determine what type of triangle. So we're going to plug it into our Pythagorean theorem and see what we get. So we're going to go 4.3 squared plus 5.2 squared equals 6.1 squared. We don't know actually what it's going to be yet, but we'll find out. So 4.3 squared is 18.49. 5.2 squared is 27.04. And 6.1 squared is 37.21. So 18.49 plus 27.04 is 45.53, which is greater than 37.21. Little c, little triangle, it is acute. Let's look at another example. All right, so we got 2.1, 2.8, and 3.5. So first thing we want to know, is it a triangle? And 2.1 plus 2.8 is 4.9, which is greater than 3.5. So we've got a triangle. So now let's plug it into our Pythagorean theorem and see what kind of triangle we have. Okay, 2.1 squared is 4.41, and 2.8 squared is 7.84, and 3.5 squared is 12.25. 4.41 plus 7.84 is 12.25, which equals 12.25. So it is a right triangle because they're equal. That solves our Pythagorean theorem. For whatever reason, I skipped over the one before. So we have segments 14, 15, and 11. So first of all, is it a triangle? So I get my two small sides, set them equal to the big side. 25 is greater than 15, so we do have a triangle. So let's plug it into our Pythagorean theorem. All right, so 11 squared is 121, 14 squared is 196, and 15 squared is 225. 121 plus 196 is 317, which is greater than 225, which makes it an acute triangle because small c, small triangle. All right, and the last one. So first of all, do we have a triangle? So we get 2.8 plus 4.6 equals 7.4. So 8 plus 6 is 14, 5, 7.4 equals 7.4. So it is not a triangle. We get to stop, and we are done.